Hello, good evening, welcome to my presentation. I'm Mikhail, I'm studying in Technical University Berlin. I'm pursuing Bachelor in Energy Engineering. I love this field and I would like to tell you today about one type of electricity production. My aim is to explain you what a gas turbine is, how does it work, how to increase its efficiency up to 92%. General overview of the technology, also advantages and disadvantages. How works cogeneration and combined cycle gas turbine. The situation in the economic space shortly and a real example of a power plant. On the first slide of my presentation, you see the scale of the turbine shaft. The shaft is the main part of it. And this is a turbine shaft installation for a power plant in Munich. And this is a modern video. Turbine on the video is much larger. Links to original videos in German language are in description. This figure shows the cycle of a power plant with a gas turbine. First, air comes into the compressor. The compressor generates high pressure and therefore high temperature. The air enters further in the combustion chamber. The air and gas are mixed and burned in the combustion chamber. A large amount of energy is exuded in the form of temperature and pressure. The turbine turns this energy into mechanical energy. Through a shaft, a small part of energy will be delivered again to the compressor. Another large part of this energy will generate electricity in generator. The generator is on the same shaft with the turbine and compressor. After the turbine, the exhausts can be removed to outside, but the exhausts are still very hot, about 300 degrees Celsius. The heat is transmitted from the exhaust to the water in the heat exchanger. Overheated water and steam rotates another turbine. This way, this plant provides high energy efficiency. This is appearance of the turbine in the animation. On this diagram, you can see typical keys of a compressor, combustion chamber, heat exchangers, and a turbine. The letter W means work. The compressor, gas turbine, and generator are on the same shaft, but the steam turbine is separately on another generator, and this key means a pump for water. We see here the efficiency in comparison with other types of power plants. Let's look for the other advantages. Low CO2 emission, low specific investments costs, short construction time. High flexibility means that the turbine can be turned on or off for a couple of hours. This is important in peak loads. Low pollution and noise emissions. High acceptance among the people. Disadvantages are only the cost for imported gas. Let's look more closely at the part with the steam turbine. Now, how to increase the efficiency up to 92%. The mixture of steam and water after the steam turbine is still very hot, already not enough hot for producing of more electricity, but his heat can be used for building heating. This solution eliminates energy losses on condensation. We can see on this diagram the energy efficiency of the cogeneration and combined cycle gas turbine. Efficiency is up to 92%. Energy production in Germany. We see here that gas doesn't predominate as a source of energy. This graph shows us disadvantages of gas turbine. Capital costs are very small, CO2 costs are very small, but fuel costs are very large in comparison with other power plants. This graph shows investment costs. A gas turbine have an advantage. This is an example of a power plant in Munich. This power plant uses cogeneration. We see that one turbine worked about 24 years till replacement. This is a power plant plan. You can stop the video and look for more details. Almost half of Munich receives heat from the cogeneration from this power station. On this slide, the main characteristics of power plant, but in German. Here's the references. Thanks for watching. Good luck!